So today we're going to be talking about the changes from the linear parent function. So the parent function is the equation y equals x, or it can also be written as f of x equals x. Okay, so if we're thinking about the normal equation from a line, which is y equals mx plus b, you can see that we don't have an m or a b here, we just have an x. And that means that our slope is going to be 1 and our y-intercept is going to be 0. So it's going to go right through the origin. The table, as you can see here, so if y equals x, okay, then these are going to be the exact same, okay? So that would mean that y would be -3 when x was -3. Y would be -2 when x was -2, and so on and so forth. So each of these is going to match exactly, okay? This is the simplest equation, a slope of 1 and a b of 0. And so we are going to see some changes from the simplest form to give us some of the more complex lines that we practiced graphing last week, okay? So a vertical shift is going to be f of x plus d, okay? So g of x is going to be the new function, and f of x is going to be the old function, which is the parent function, okay? So f of x at this time is going to be the parent. I'm just going to put parent so it'll fit, okay? So if we have the parent function plus 1, we can see in the new function, our graph is going to shift up 1 unit. Okay, and then on the other side of that, if we see a -3, they take the parent function and then subtract 3, we will see a shift down 3. All right, if you see something that's being multiplied, then that is going to change the steepness or the slope of the graph. Okay, so if it's going to times 3 times the parent function, our new slope is going to be 3. We can say that our new graph is going to increase by a factor of 3. Okay, and then here we see, okay, 1/2. Well, it used to be 1, and now we have 1/2. So that's actually going to be a decrease if our new slope is 1/2. So we are going to say that the graph, we don't need this becomes, it's going to decrease by a factor of 1/2. Okay, so the first type of change, this is going to be the new b value of the graph. That's going to give the graph a new slope intercept, and changes in the steepness are going to give the graph a new slope. Okay, and then this last type of change here, changes in direction. If it has a negative, we take the parent function and make it negative, the graph reflects over the x-axis. Okay, so basically it's just flipping. Okay, so it used to be a positive slope with going up and to the right, and now it's going to be a negative slope that goes down to the right. Okay, so let's practice a few of these. Okay, so the first thing that we're going to do is we are going to plot the parent function. Okay, I'm going to plot the parent function in black, and then I'm going to do another, like the new function on top of it. So the parent function always starts off at 0, 0, and then the slope is 1. So it just goes up 1 to the right 1, here, down 1 to the left 1, and that's what our parent function is going to look like for every single graph. It's just the most basic form of a line, which is y equals x, okay? So in black here, we have our f of x, all right? Now I'm going to graph the g of x in pink, okay? So every point that I have on my graph of f of x, I just need to add 3. So instead of starting here at 0, 0, I need to add 3. So I'm going to start at 0, 3, okay? Instead of being here at 1, 1, I need to go up 3 to 1, 4, okay? Instead of being at 2, 2, I need to go up 3 to 2, 5, okay? And by now you guys can clearly see the pattern and it's going to look like this all the way down. Okay, so this is our new line, our new g of x line, and then it wants us to write out the changes. Okay, so let's say that g of x has a vertical shift, up 3. Okay, now let's look at the next one. Okay, again, first thing that we're always going to do is plot our parent function. So I'm going to do that again in black, our f of x equals x, the parent function, and I'm going to say, okay, it starts here at 0, 0, and it has a slope of up 1 over 1, down 1 here. Okay, so this is going to be my parent function. Okay, now we're going to do the next one, g of x, right? So g of x equals 2 times f of x. Well, since f of x equals x, I can just substitute an x in here. So g of x equals 2x, right? So I'm still going to start at 0, 0 because my x value is 0 and 0 times 2 is still 0, right? But instead of having it here at 1, 1, well, 2 times 1 is 2, right? 2 times 2 is 4, okay? Same thing, 2 times negative 1 is negative 2. 2 times negative 2 is negative 4. So my graph increased in steepness, right? So we can say here our changes were g of x had a rate of change increase, which is a slope increase, right? Rate of change means the same thing as slope. Rate of change increase by a factor of 2. We just multiplied it by 2. Okay, let's drop down to the next one. We can see negative 1/3 here, right? So same thing, first thing we are going to plot our parent function, f of x equals x. So I always start at the origin, 0, 0. I have a slope of 1. So I have my points here. And then in my g of x, in my new function, okay, I have 1/3 times f of x, or excuse me, negative 1/3 times f of x. Well, I know f of x equals x, so that's going to be the same thing as negative 1/3 times x, right? And so I'm still going to have my first point at the origin, but now my slope is going to be negative 1/3. So I'm going to go down 1 to the right 3, okay? Or up 1 to the left 3, okay? So that is how my new line looks. So this actually has 2 changes associated with this here. We have one change that is associated with this negative, and then we have a second change that is because of the 1/3, okay? So let's do the 1/3 first. I'm just going to write it in blue so you can see where it came from. There is a rate of change decrease by a factor of 3, or excuse me, 1/3. Okay, and the second change is a reflection, reflection over the x-axis. Okay, the negative is what causes that reflection. So you can see we used to be going up to the right and now we're going up to the left, and that's due to the negative. Okay, and then the graph flattening out is due to the 1/3. Right? Let's go ahead and get to our last example. Okay, here we have quite a few changes. So we're going to go ahead and get our parent function here onto the graph. Starting at 0, 0, we have a slope of 1. And then we have our changes, okay? So again, we have f of x equals x, okay? So we can substitute x in for f of x here. So the new graph, g of x equals negative 2x minus 2, okay? And we're going to have a few different changes here, okay? So we're just going to go ahead and graph this equation. We have to start at negative 2, and then we have a slope of negative 2 also. So it looks like this. This is pretty different from our original line, right? And the first change that takes place is going to be, I'm going to do each one in a different color so you can see exactly where it came from. The first one that takes place is because of this minus 2 at the back, and that is a change in the b value. Okay, so that makes a vertical shift down 2 units. Okay, so used to, we had our point here at 0, 0, and then you can see that it shifted down by 2 units, and that's because of that minus 2 at the back. Okay, our second change is going to be due to this 2 right here. Okay, so that is going to cause a rate of change increase by a factor of 2. Okay, so used to, I was going up 1 over 1, and now you can see in my new line I'm going up 2 over 1. All right, and then the very last change is due to this negative right here. Okay, and that is going to cause a reflection over the x-axis. Okay, and you might have heard this in 8th grade called a flip, right? I used to be going up and to the right, and now you can see my line is going up to the left, and that is because of the negative. It had my line flip over the x-axis.